Okay, so in this video we're going to talk about continuity and discontinuity. So we'll start with a definition of continuous. So a function is continuous at a point x equals c if the following three conditions hold. First, f of c exists, the function exists at c. The limit as x goes to c of f of x exists. And third, the values of 1 and 2 match. Okay, so let's set that aside, and we'll just make a few comments. First, polynomials are continuous. The limit at a value always exists, and it matches the function output at that value. Furthermore, rational functions are also continuous as long as their denominator is not 0. And functions that are not continuous, that they break one or more of these three conditions, are called discontinuous. More specifically, discontinuous at the point where they break. Okay, so let's look at an example of a function that has some discontinuities. So let's consider this rational function x minus 2 over x squared minus 4. And the first thing we're going to do is just graph this function. So here's what the graph looks like. So it has an asymptote at -2. And it has a hole at +2. Okay, so this function has two types of discontinuities. So it has one at -2. This is called a blow up, or going to infinity. And it has one at +2. This is called a hole. And the reason that it's discontinuous here, we go back to our definition. So the reason it's discontinuous at -2 is the limit does not exist there. And the reason that it's discontinuous at 2 is the function doesn't have an output there. It has a hole there. So f of c does not exist. It doesn't satisfy the first condition. And it can't satisfy the third condition because there is no first condition. One could think of continuity as connectedness. So this function is not connected at 2, and it's not connected at -2. So it's not continuous. All right, let's look at another example. And let's think about the discontinuities in this example. So this function is a piecewise function. It's x for x less than or equal to 1, x minus 1 over x squared minus 3x plus 2 for x between 3 and 1, and it's x minus 2 for x greater than or equal to 3. So again, we're going to draw this function. So the places where it switches between the different formulas are at 1 and 3. So before 1, it's x. And then from 1 to 3, it's this rational function. I would use a calculator to graph this rational function, but I'll just tell you what it looks like. So it has this asymptote at 2. And then from 3 on, it's this line x minus 2, which looks like this. Okay, so this function has two types of discontinuity, two places where the function is no longer connected. One is at x equals 1, and this is called a jump discontinuity. The reason it's discontinuous here, it's not continuous, is the limit does not exist at 1. Remember, that's one of the conditions. And then the next place it's discontinuous is at 2, and this is for the same reason that it was discontinuous in the last example at -2. The function blows up here. It has an asymptote. It kind of goes to negative and positive infinity. And then everywhere else, or all other x, it's continuous. Okay, I hope you found this video useful.